All right, gentlemen, welcome to today's async, and we're going to talk about U substitution. So we tend to think of U substitution as this is the chain rule backwards. ECKWARDS. What do I mean by that? So the derivative, we need a chain rule. To undo the chain rule, we use U substitution. And start kind of with a motivating example. Let's take this derivative. Right, this is the derivative that we need a chain rule for. I'm missing a parenthesis here. But if I take this derivative, I'm going to get derivative outside when we leave the inside alone. So we're going to get cosine x squared plus 5x plus 6 times the derivative of the inside, 2x plus 5. Right? 2x plus 5. So this is our chain rule. Our chain rule gives us this as an answer. Now, if you remember the way integration works, I want to start here and end up above. I want to start here and I want to end up here. And of course, we can just stare at this and say oh, okay, that might be a chain rule. And we say, all right, well, cosine, sine, blah, blah, blah. Okay, maybe we can figure it out. It would be nice to have some algebraic way to go about doing this. And that's what U substitution is. It gives us an algebraic way to solve these types of problems, to go in the opposite direction. Okay? So problem 2 is just actually asking us to go the other direction. So we automatically know this is sine of x squared plus 5x plus 6 plus c, right? But we want to figure out algebraically that this is the case. And we do something called U substitution. So let's kind of break it down into steps, and we'll do them for this problem. So step one is choose U. We choose U and du dx. We need to choose the two of these, and really once we choose U, we can figure out what du dx is, because that's just the derivative of U. Now, how do I choose U? Well, I look at my problem, and it's the thing that looks like it's being plugged into another function, right? So I notice here, I have kind of this function times this function, and this function looks like it has that guy plugged in. So it's always a thing that looks like it's being plugged into another function. And really just finding U comes with doing 412 examples. There's no great way of doing it, but we can always find U just by seeing what we think is plugged into another function. And then, we see if it works. So we'll talk about how we know if it works or not. So we're going to let U, in this case, be x squared plus 5x plus 6 du dx. If you remember, as we take the derivative with respect to x, that's 2x plus 5. Okay? Now, we already have one step that makes us feel like we're perhaps going in the right direction. This, our du dx, appears somewhere else in the problem. So that gives us hope that we're going along the right direction. Step two is we solve for dx and substitute. S-T-I-T-U-T-E. So du over dx, we can solve for dx. We get that dx is equal to du over 2x plus 5. And then we can substitute. So this is the integral of 2x plus 5 times cosine. Now I could put x squared plus 5x plus 6 in here, but I have a substitution for it, so we're going to call it u. Make our substitution for u. And dx, well, dx is really du over 2x plus 5, so this is du over 2x plus 5. Okay, now here's another hint that we got this right. 3. Simplify. Right, so we can notice here that this guy and this guy can cancel. So this is equal to the integral of cosine of u du. Okay, and this is where that kind of subtlety of what's going on with that last, with the du, with the dx, with everything, it's just telling us what we're taking an integral with respect to. Telling us what we're taking an integral with respect to. In this case, we're taking an integral with respect to u, and that's what's really important. We have step 4. If all x's are gone, we integrate. All right, and there might be some algebraic steps you have to take in here, but we'll save those kind of more complicated problems for another day. For now, excuse me, that's a 2. For now, we just have to integrate. Integral of cosine u. Well, we know this is step 4. This is equal to sine of u plus c. And then our final step is we make another 5. Substitute back. Substitute back. So we get 5 is sine x squared plus 5x plus 6 plus c, because x squared plus 5x plus 6 is u. And you notice that we actually get the answer that we want, right? Like we got the original problem, sine x squared plus 5x plus 6. And we get this extra plus c, but that's okay. Remember, we're always going to have that constant plus c, but we got the problem the way we wanted to. And this is the method of U substitution. You just keep each of these steps every single time. So for the rest of the video, I'm just going to kind of do some examples for you. I'm not going to write out these steps in such great detail, but it should kind of get you a good start on U sub. All right, so we have this guy here, and we notice that it looks like u equals x squared minus 3x plus 1 is being plugged in. And I made a typo in here. We want this to be 9. So we're going to fix that. We'll fix that right now. All right, so we think that looks like u. Du dx is 2x minus 3. Solving for dx equals du over 2x minus 3. Now we substitute in. So we have the integral of 6x minus 9 e to the u. That's a 4. E to the u. Du over 2x minus 3. Okay, and now we notice that we can't straight cancel right here. We can't straight cancel. So what we have to do is we have to get a little creative with our algebra. I mean, and not particularly creative. We notice we can factor out of this first guy here. This is 3 times 2x minus 3 e to the u du over 2x minus 3. And we'll see that this and this cancel, which gives us that this is equal to the integral, it looks like an S, the integral of 3 e to the u du, which again, using our new rules, this is 3 e to the u plus c. And then we have to substitute back in. which is 3e to the x squared minus 3x plus 1 plus c. Again, if we take the derivative here, we'll get the original function we started with after we made that 9 for a substitution. Okay. Problem 4. Again, I see another issue, so we're going to make this 8x down here in the denominator, 8x. And one tip is that whenever you have a fraction, and you want to take the integral, we're going to do U substitution, we want to use the bottom as our U. So we're going to let U equal 8x minus 2x to the fourth du dx is equal to 8 minus 8x cubed. So dx equals du over 8 minus 8x, 8x cubed. Right, and we substitute in. This is the integral of 8x cubed minus 8 over u du over 8 minus 8x cubed. Okay? And we want to cancel, and we're very close to canceling, right? What's the difference between this guy and this guy? Well, there's a minus sign in the middle, and they're in this wrong order, right? So when there's a minus sign in the middle, and they're in the wrong order, you can cancel them, but you get a factor of -1. Another way of saying that is that I can rewrite this as -1, 8 minus 8x cubed over u du over 8 minus 8x cubed. And now this guy and this guy do cancel, which gives me -1 over u du. The integral, that negative just hangs around. Integral of 1 over u is ln of u in absolute value plus c. Sorry for Nilla, plus c. And then we have to make our substitution back in. So u is minus ln, u is 8x minus 2x to the fourth. Okay, so there's another u sub. Now I believe I have 2 more left to do for you. Number 5. Number 5 is kind of a cool problem. Why is that? Well, you will see in a second. This works anytime there's a linear term to a power, right? So that looks like a line. We'll let u equal 2x minus 3. We get du is equal to 2. Du dx is equal to 2, which gives us that dx is equal to du over 2. All right, so there's a du over 2 is our dx. And if we integrate this, this is the integral of u to the 8th times du over 2. And luckily, we can pull that 2 out as 1/2. Times the integral of u to the 8 du, which is equal to 1/2 times u to the 9 over 9 plus c, which is equal to 1/2. We substitute back in. Our u is 2x minus 3 to the 9 over 9 plus c, and we can simplify if we want. All right. Now, for problem 6, we did this in class yesterday, but I want to do it with U substitution. I want to show you that we can do U substitution. I would encourage you to pay very close attention because you're going to have to do a problem similar to this on your async assignment. All right, so what is the integral of tangent dx? Well, we saw we can simplify this as the integral of sine x over cosine x dx. And we saw that it's quite often it's useful to let our denominator be our u. So we'll let u equal cosine x du dx is equal to negative sine of x, which gives me that dx is equal to du over negative sine of x. Okay, we make our substitution. I get this is the integral of sine of x over u. Dx is du over negative sine of x. And we notice that these guys cancel and leave us with a negative 1. So this is the negative integral of 1 over u du, which is negative ln u plus c, which is equal to negative ln u is cosine of x plus c. Ran out of room here. Plus c. All right, so there is U substitution. If you're stuck on any of these problems, watch the video again. I want you to do all 6 of these. They should all be doable. I checked a couple times, but of course there's always the possibility that I made a mistake. So, good luck. Let me know if you need any help.